Hi everyone, my name is Jibran. I am from CFCG section. My topic is secure inter-service communication. Inter-service communication enables data exchange between microservices. Security ensures data confidentiality, integrity, and authenticity. Cloud-native architecture rely heavily on secure interconnections. Failure to secure channels may lead to major vulnerabilities. Security mechanisms evolve as cloud complexity grows. Importance in cloud system. Microservices often communicate over network in public or hybrid clouds. Every interaction point introduces a potential attack vector. Encryption and identity management safeguard and sensitivity information. Security ensures compliance with organizational and industrial standards. Reliable communication builds customer and partner trust. Communication types. Synchronize. API calls via REST gRPC between services. Asynchronous. Message queues or event streams for decoupling. Each type requires different encryption and authentication models. gRPC supports built-in MTLs, while REST often use OAuth 2.0. Hybrid communication models are common in large-scale apps. Security threats. Main in the middle MITM. Attackers during API calls, unauthorized service impression or spoofing. Data tampering during message transmission. Relay attackers exploit token reuse. Insider threats from compromised services. Core security principles. Confidential. Encrypt all inter-service data transfer. Integrity ensures messages are unalerted using cryptographic checks. Authentication. Verify both sender and receiver identifies. Authorization. Enforce access based on roles or scopes. Auditing. Log and monitor all communication events. Mutual TLS MTLS ensure two-way authentication using certificates. Both services validate each other identities. Automatically provides encryption for data in transit. Reduces the risk of impersonation attacks. Ideal for zero trust cloud environment. OAuth 2.0 framework used to delegate limited access between services. Relies on access token instead of credentials. Support scopes for fine-grained permission. Integrates with identity providers for verification. Widely adopted across SaaS and microservices systems. JSON Web Token is shortcut from JWT. Compact tokens used for identity and claims exchange. Digitally signed using secret or public-private key. Allow decentralized validation without shared state. Include expression, issue, and audience claim. Commonly used with API gateways and authentication 2.0. API gateways act as the single entry point for service request, handle authentication, rate limiting, and logging, reduce direct exposure of background services, enable centralized policy enforcement, work seamlessly with IAM and monitoring system. Identity and access management IAM manages services, accounts, and rules across cloud platform, implements least privilege principles for inter-services access, supports key rotation and credential management, integrates with APIs, gateways, and service meshes. Critical for controlling and auditing permissions. Service mesh overview. Provide infrastructure layer for managing service communication. Automatically secure traffic using MTLS. Supports retreats, load balancing, and failure recovery. Adds observability with metrics and tracing. Popular tools ICTO linked console. Zero trust architecture assumes no services is inherited trusted with a network. Enforces verification for every request. Combines identity validation, encryption, and policy enforcement. Microservices adopt strong authentication and least privileges. Improves resilience against lateral movement attacks. Data encryption standard. TLS 1.3 provide modern encryption for communication. AES and RSA used for symmetric and asymmetric encryption. Certificates used by trusted certificate authorities. Key rotation policies enhance long-term security. Sensitivity metadata should also be encrypted. Network layer security. Firewalls and VPCs restricted service to service traffic. Private network isolates sensitivity services. Network ACLs define traffic flow policies. Load balancers manage secure traffic distribution. Intrusion detection monitors for anomalies. Service architecture model. Static credential decrypted for modern system. Dynamic tokens are shortly lived credentials. Mutual certificate based authentication. Federated authentication using CISO or identity providers. Ensure revocation and renewal mechanisms are automated. Monitoring and logging. Collected logs for every inter-service interaction. Use SIS system for real-time analysis and alerts. Correlator logs across microservice for root cause analysis. Ensure secure log transmission and storage. Complaints audit relay or traceable logs. Performance security balance. Encryption introduce latency optimized with caching. Use hardware accelerator for cryptographic operation. Balance between security depth and resource utilization. Apply adaptability rate limiting and circuit breakers. Monitor end-to-end latency impacts of security layers. Automation security management. Use DevOps to integrate security into CI/CD pipelines. Automated certificates provisioning and renewal. Implemented policy has code for consistent reinforcement. Test communication paths using penetration tools. Ensure rollback safety during security updates. Container and orchestration security. Secure Kubernetes service to service traffic using network policies. Use sidecar proxies for traffic encryption in pods. Apply role-based access control RBAC. Monitoring inter-container communication via ISO metrics. Automated secret management using tools like HashiCorp Vault. Case study 1. FindTech app. Payment and user verification services communicate securely using MTLS. API gateways enforce authentication 2.0 with JWT tokens. IAM control backend access for transaction APIs. End-to-end encryption ensure PCI DSS compliance. Continuous monitoring detecting anomalies in request pattern. Case study 2. Healthcare cloud. Patient data exchange securely among analytics and EMR services. HIPAA. Complaint encryption enforced via service mesh. Access restricted through IAM and scope tokens. All communication logged and audited. Reduces complaint risk and enhance trust. Security challenge. Certificate management complexity and expire risk. Token leakage through improper logging. Configuration drift across an environment. High latency under full encryption workloads. Human errors during IAM role configuration. Mitigation strategies. Automated certificate rotation and validation. Limit token lifespan and encrypted logs. Use infrastructure as a code for consistency. Employ caching and asynchronous communication. Provide continuous training for DevOps team. Future trends. AI-driven anomaly detection in service traffic. Post-quantum encryption for long-term security surveillance. Inter-service security enhancement. Decentralized identity framework gaining traction. Interaction of blockchain for trustless communication. Security challenges. Certificate management complexity and expert risk. Token leakage through improper logging. Configuration drift across environment. High latency under full encryption workloads. Human errors during IAM role configuration. Automation security management. Use DevOps in integrated security into CI/CD pipelines. Automate certificate provisioning and renewal implement policy as a code for consistent enforcement. Test communication paths using penetration tools. Ensure rollback safety during security updates. Container and orchestration security. Secure Kubernetes service to service traffic using network policies. Use sidecar proxies for traffic encryption in pods. Apply role-based access control RBAC. Monitor container communication via ISO metrics. Automated secret management using tools like HashiCorp Vault. Case study 1. FinTech app. Payments and user verification services communicate securely using MTLs. API Gateway enforced OAuth Authentication 2.2 with JWT tokens. IAM control backend access for transaction APIs. End-to-end encryption ensure PCI DSS compliance. Continuous monitoring detect anomalies in request pattern. Mitigation strategy: automated certificate rotation and validation, limit token lifespan and encrypted logs, use infrastructure as a code for consistency, employee caching and asynchronous communication, provide continuous training in DevOps team. Future trends: post quantum encryption for long term security, serverless inter-service security enhancement, decentralized identity frameworks gaining traction, integration of blockchain for trustless communication. Conclusion: secure inter-service communication ensures cloud reliability, combines MTLs, OAuth, IAM, and zero trust principle. Regular monitoring and automation strengthen defense. Balance performance and protection through careful design. Security first. Culture is essential for modern cloud system. Thank you all.